I'm working on this Unit 8 review, and I was in the middle of number 9 when my iPad said no more storage. So I'm going to pick it back up where I was. I am trying to find vertical asymptotes. So I factored the denominator into x plus 3, x minus 1. I looked to see if anything canceled out. If it did, that would make wholes, but nothing cancels out. So to find the vertical asymptotes, I take both of my factors in the denominator and I set them equal to 0. So if I set my first factor, x plus 3, equal to 0, I would get negative 3. And if I set my second factor, x minus 1, equal to 0, and if I solve that, I would get x equals 1. Those are my vertical asymptotes, positive 1 and negative 3, which is C. Bless me. All right, the next one. Number 10, determine the values of x for any points of discontinuity. So that's talking about holes. Whenever it says any points of discontinuity, they're talking about any holes. Okay, so I want to factor my denominator, numerator if I could, but my numerator doesn't factor. There's no GCF. It's not a difference of squares. But the denominator, I can factor a times c rooftop. Easy one. So a times c, 1 times 6 is 6. I want the numbers to add to make 5. And the numbers that multiply to make 6 and add to make 5 are 3 and 2. Because 3 times 2 is 6 and 3 plus 2 is 5. Okay, so my denominator is going to factor with an x with a plus 3 and an x with a plus 2. I'm just going to go ahead and scribble out my original denominator because this is how it factored. Okay, at this point, do you see anything that can cross out? The x plus 3's can. The x plus 3 on top can cancel with the x plus 3 on bottom. And so that's what makes a whole. Whenever you have a factor in the denominator that cancels with a factor in the numerator, that's where your whole comes from. So x plus 3, if I set that equal to 0 and solved it, I would get negative 3. That's where my whole takes place. Also known as the point of discontinuity. So x equals negative 3 is answer choice A, and that's my whole. Now, if I was to write this answer all simplified out, since there's nobody on top, that means it's understood to be a 1, and in the denominator I have x plus 2. That would be my problem all simplified out. Now, if it asks for a vertical asymptote, then that would be where my denominator equals 0, and that would be at negative 2 if it asks for that. So the factor that is in the denominator that cancels out with the numerator, that makes a whole. And the factor that's in the denominator that doesn't cancel out, that makes a vertical asymptote. So that's the difference between those. All right, this one here. Now, I could graph these in my calculator and see which picture matched. I could do that. But I'm just going to look at the denominators so you can see where the vertical asymptotes would be. Now, first of all, nothing crosses out in any of these, so there's no holes. So an A, my vertical asymptote, would happen where my denominator equals 0. And if I set that equal to 0, I would get 1. So this one would have a vertical asymptote at 1, which this graph does, but it has a second vertical asymptote, and this only has 1, so it can't be this. This one only has 1. If you set x plus 1 equal to 0, you would get negative 1. So this one has a vertical asymptote at negative 1, but this graph doesn't even have a vertical asymptote at negative 1, so it can't be that. Okay, C, if I set both of these factors equal to 0 in the denominator, this one would give me a negative 3, and this one would give me a positive 1. And that is exactly where my two asymptotes are, my two vertical asymptotes. So that must be it. This one here would give me a positive 3 and a negative 1, and that's not where they are. So C's our answer. Okay, on to number 12. Okay, number 12. An appliance store manager noted that the weekly sales varied directly with the amount of money spent on advertising. If last week's sales were $10,000 and $2,000 was spent on advertising, what should sales be during a week that $1,200 was spent on advertising? Okay, so notice the words varied directly. When it says varied directly, that's direct variation. So that's when you have the equation y equals kx. And this stands for y varies directly with x. But this didn't use any mention of x and y's. It had words. So it says that weekly sales, so weekly sales would be the y. So I'm going to use, what do I want? I'll just use S for sales. Varied directly, so that's equals K, with amount of money spent. Okay, so this is money spent. So I'm going to just use an MS to represent money spent. So weekly sales varied directly with money spent. So it's of the same format as y equals kx. It's just I had to put the letters that the problem was talking about. So here when it says if last week's sales were 10,000, well 10,000 is going to go into the S because S represents the weekly sales. And then when 2,000 was spent on advertising, so the money spent, that was 2,000. So that goes into my MS. So to solve for K, what would I have to do? I would have to divide by 2,000. And that would give me my K. And 10,000 divided by 2,000 is 5. So I know that K is 5. Okay, so now I can rewrite my equation. So S equals, now where the K is, I now know that my K is a 5. And I'm going to put my MS again for money spent. Okay, so now let's see what it says. It says, what should sales be during a week that $1,200 was spent on advertising? Okay, so $1,200 was spent on advertising, so that's money spent, so that goes into MS. So I put $1,200 where the MS is, and if I work it out, that will tell me my weekly sales. And that's what it's asking. What should the sales be during a week? So I just need to take 5 times 1,200, and when I do that, that gives me 6,000. So $6,000 is what the sales should be for the week. So that is an example of direct variation. So we saw the words varies directly, which is the indication of direct variation, y equals kx. Okay, next one. The distance a car can travel on a certain amount of fuel varies inversely. Okay, so this time we have inverse variation. And inverse variation is y equals k over x. So this stands for y varies inversely with x. Okay, but let's use the words that they talked about. So it says the distance a car can travel varies inversely. So instead of y varying inversely, its distance varies inversely. So d equals, and it varies inversely with speed. So instead of x, it varies inversely with speed. So I'm going to use an S there. So distance varies inversely with speed. Okay, now let's plug in what they told us. If a car traveling 50 miles per hour can travel 336 miles, how far could the car travel at 60 miles per hour? Okay, so it's traveling 50 miles per hour. That is its speed. So that's going to go into the S. And it travels 336 miles. That's the distance. So that goes here. So to solve this for K, I need to get rid of division of 50. So to get rid of division of 50, I would multiply both sides by 50. And so if I do that, these 50s cancel out on the diagonal, leaving k. And 50 times 336, let's see. 50 times 336 makes 16,800. Okay, so now I have my k. So now I can put this k into the k. So instead of d equals k over s, it's going to be d equals 16,800 over s. Okay, so the question says, how far could the car travel? So we want to know the distance at 60 miles per hour. So 60 miles per hour, that's its speed. So I'm going to put 60 into the s. And that will give me my distance. And if I take 16,800 and I divide by 60, that makes 280. So the distance this car can travel is 280 miles. And that's my answer to number 13. 280 miles. And that was an example of inverse variation. Y equals k over x. So direct variation is y equals kx, and inverse is y equals k over x. Okay, I have not left much room for these next couple problems. So I grabbed another piece of paper so I would have some room to work them. Okay, number 14 is wanting me to solve this equation. All right, so I need to figure out the least common denominator. My denominators can't factor. There's no GCF. They're not a difference of squares. And so the only thing I see in the denominator is n minus 3, so that would be my least common denominator. It happens once here and once here, so I just need it once. So I am going to multiply everything by n minus 3, and it's going to knock the fractions out. Okay, so I'm going to recopy my n over n minus 3, and I'm going to multiply that with my least common denominator. I'm going to recopy plus n, and I'm going to multiply that with my least common denominator. And then I'm going to recopy my 7n minus 18 over n minus 3. And I'm going to multiply that with my least common denominator. So when you have an equation, you can just multiply everything by the least common denominator, and that's going to kick all the fractions out. So the n minus 3's that are on the diagonal, they're gone. All I'm left with is n. Here, I would have to distribute the n. So n times n is n squared, and n times negative 3 is negative 3n. On this diagonal, the n minus 3's can cancel out. Shoop. All I'm left with is 7n minus 18. Okay, so because I have an n squared, anytime you have a squared term, x squared, n squared, r squared, p squared, you need to make one side say equals 0. So you can either solve by factoring or quadratic formula, completing the square, something like that. Okay, so first I'm going to go ahead and combine like terms on the left side. So n minus 3n makes a negative 2n. So I have n squared minus 2n. And now I'm going to work on making one side say equals 0, because that's what I need to do to solve my quadratic. So I like my n squared to be positive, so I'm going to leave him alone. So to move this 7n, I would have to do the opposite and subtract it. Since it's positive, I would have to subtract it. And to move this negative 18, I would have to do the opposite and add it. So on the right side, 7n minus 7n is 0, negative 18 plus 18 is 0, so I have nothing left on that side but 0. On this side, my n squared comes down. Negative 2n minus 7n makes negative 9n. And then the plus 18 can just come down. Okay, so now I want to factor this if I can factor, and if I can't, then I will use quadratic formula. So there's no GCF, it's 3 terms, so I'm going to a times c rooftop, and it's another easy one. So a times c is 18, because 1 times 18 is 18. I want the numbers to add to make negative 9. And do you know who does that? Negative 6 and negative 3. Those multiply to make 18, and they add to make negative 9. So I can go straight to my parentheses, put minus 6 in the back, put minus 3 in the back, and put the letter I'm working with in the front. Okay, now I'm going to set each of these factors equal to 0 and see what I get. If I set n minus 6 equal to 0, I get positive 6. And if I set n minus 3 equal to 0, I get positive 3. So those are the two answers I got. Now, one thing I didn't do at the very beginning was look at what would put a 0 in the denominator. Because you know how you can't ever have a 0 in the denominator? Well, if you set n minus 3 equal to 0, what would you get? Positive 3. So I know that n cannot equal a positive 3. This is where it would be undefined. So this problem would not work. It would be undefined if n was a 3. Because 3 minus 3 makes a 0 in the denominator. So when I got this answer of 3 down here, I know that can't be an answer, because that would put a 0 in the denominator. So the only answer that works is the 6. So the answer to this problem is B. Okay, number 14. This is an inequality that I have to solve. Okay, so first let's just talk about where this problem would be undefined. This problem would be undefined if m was a 0. If 0 was there, you'd have a 0 in the denominator. You can't have that. Okay, so I know this problem is undefined where m is 0. Okay, so now I'm going to solve this equation. Instead of using the greater than, I'm using an equals. I need to figure out my least common denominator. Do you know who it would be? M. That's the only thing we have in the denominator, so that would be your least common denominator. So because it's an equation, I can multiply everything by the m, and it's going to knock the fractions out. So I'm going to recopy my 7. I'm going to multiply it by my least common denominator, m. I'm going to recopy my minus 3 over m. And I'm going to multiply that with my least common denominator, which is m. And then I'm going to recopy my equals 18 over m. And I'm going to multiply that with my least common denominator. Okay, at this point, 7 times m is 7m. My m's on the diagonal cancel. All I'm left with is minus 3. And over here, the m's on the diagonal can cancel, and I'm just left with 18. Okay, so I'm going to solve this equation. Next, you would add 3. If you added 3, you would get 21. And then next, you would divide by 7. And if you divided by 7, you would get positive 3. And this is where the problem is equal. It's not where it's greater. So I'm going to have to use a number line to figure this out. Okay, so I'm making my little number line. I know this problem doesn't work when m is 0. So that is one of my places I'm going to put on the number line. I know this problem is equal at the 3, and I don't want to know where it's equal. I want to know where it's greater. So 3 is the other thing that I'm going to put on the number line. And I need to check these 3 locations: a number smaller than 0, a number between 0 and 3, and a number bigger than 3. And I have to put them back into my original equation. Okay, so this is where it gets kind of funky. So first I'm going to try negative 1, because that's a number smaller than 0. So I'm going to put negative 1 here and negative 1 here. Okay, so if I have that, I have 7 minus 3 over negative 1 greater than 18 over negative 1. Okay, let's see how this plays out. So 3 divided by negative 1 is negative 3, and a minus a negative 3 is the same thing as a plus 3. And 18 divided by negative 1 is negative 18. Let's see if this is true. 7 plus 3 is 10. Is 10 greater than negative 18? Yes. So I know that some of my answers are right here in this section. Okay, let's see where else my answers are. I'm going to try a number between 0 and 3. So let's try a 1. So this time I'm putting a positive 1 here and a positive 1 here. Okay, so I'm going to have 7 minus 3 over 1 greater than 18 over 1. So 3 over 1 is just a 3, so this is 7 minus 3, and 18 over 1 is just 18. Okay, so 7 minus 3 is 4. Is 4 greater than 18? No. So there's not an answer in this section. Now let's try a number bigger than 3. And I can try anything I want. I'm actually going to try 6 because that looks like it's going to work out kind of nice. Okay, so I'm going to try the 6. So I'm going to recopy 7 minus 3 over 6 greater than 18 over 6. So I'm putting 6's where the m's are. Okay, so 3 over 6 is 1/2. So 7 minus 1/2. And 18 over 6 is 3. Well, what's 7 minus 1/2? 6.5? Is 6.5 greater than 3? Yes. So I know that numbers on this side are answers. Okay, so the way this plays out, all my numbers smaller than 0 work and all my numbers bigger than 3 work. Let's see, where do we see it? It is answer choice A. So with these inequality problems, whenever you have a variable in the denominator, you need to find first where the problem won't work because it will give you a 0 in the denominator, and that'll be one of the spots on the number line. Then you're going to replace your inequality symbol with an equals, and that's going to be the other number that you put on the number line, because I don't want to know where it equals, I want to know where it's greater. So that's why that number goes on the number line. And then you have to test those 3 places. Okay, I'm going to stop the video here, and then I'm going to pick back up at number 16. See you in a little bit.